Engineer. My name is Liwen Shih. So today my main purpose is two things. One is to get data from y'all. Second thing is that I'm going to tell you how supercomputer, Internet of Things, and artificial intelligence can help you to analyze and visualize your data and then provide a decision making at the end. Okay, so let's find my garden. So this is about me. So, oh, I'm sorry. Let me start the. Okay, is it better? Okay, so I do supercomputing, quantum computing, big data, cloud, all those kind of things. So over here, this is a quantum supremacy from Google. This is me with D-Wave system, IBM Q. This is me in Oracle National Lab. This is the summit, which is the second or the largest computer in the world. This is me with the earthquake group in the nation, and I do space, I do oil and gas and Martian radiation, all kind of research projects. I have earned many awards. This is education for NASA Stella. This one is for the earthquake. I was the first fellow for XC Campus Champion to work on the largest computation in the world. This is when I was Fulbright. I went to Chile to help them using drone to monitor their wildfire detection. So the data visualization is very important because every 1% improvement in data visualization, you can improve 7% of discovery. So this is show that John Snow at the 19th century used the map to map all the person that gets sick from this cholera, and then they find out that the water is the problem. So then we can find a way to mitigate. This one is the largest earthquake simulation in the world. So in 2014, this was the global achievement. So this is a code that I'm working on. It's called Shake. And so this is to simulate and visualize the movement of California earthquake at a magnitude 8. So I was in this project. I was the nation's first fellow for EXCEED, Extreme Science Engineering. And then California really thanked me, with the shirt and hat and all that. So I saved them about $284,000 every time they run the earthquake code. So I was in San Diego Supercomputing Center. This was EarthQ project. I was presenting at the Palm Springs. And then this is the supercomputing conference. And this is the director of the Southern California Earthquake Center. This is the person that ran all the code. And this one is the world champion on the programming for the largest computation in seismic. In 2012 and 13, I was able to help this CyberShake code, and I was able to, I cannot see right here, but I was improving the performance for 1/3 of the computation by arranging the computation to assign workers on the supercomputer cluster to minimize the network fragmentation. So by using so, I can reduce 1/3 of the cost. Each map is costing about $285,000. I'm sorry, more than that, $805,000. So I was able to reduce the cost for the electricity. This code was 2017 won the Golden Bell ACM Award, which is the Nobel Prize for supercomputing in the world. This is the Chinese team. They're very good in hardware, but they use Dr. Trey's software, CyberShake code, to demonstrate the capability of the Tangshan earthquake, 1976. There were 250,000 people perished. In supercomputing arena, what we're trying to do is from petaflop, which is 10 to the 15 computations per second. We're gonna move to exaflop, which is 2 to the 18 computations per second. That's equivalent to 32 million people doing computation by the brain, by the head, compared to 1 second in supercomputing. We are actually moving into the zetaflop, which is going to be 10 to the 21 computations per second. In this NEC computer is 4 football field of data center. So if we want 1,000 times, then we need 4,000 football fields. So because I was involved in supercomputing, I came across quantum computing. Here I was invited as a keynote speaker in India in 2020. And there I calculate almost zero cost to be able to improve 1,000 times. So we don't have to have from $200 million supercomputer to $200 billion supercomputer to be able to do the job. In 2016, the world's first and only D-Wave quantum computer company, the whole team came visit us and give us the first training on their TQ to quantum programming language. My students are doing really well. They are using the quantum computer to solve complicated problems. This is actually, like 100 by 100 Sudoku and all that. And then this one is use AI approach to design the heat sink. This is an interview of me on YouTube. You can look. So I was lucky to be able to go to Berkeley Lab last year. And we're doing some way to automate the process that I was reducing the computation time. Here right now, there's a lot of supercomputing is focusing on the climate change. So we're gonna try to go visit the Germany and try to study the IPCC assessment report. And then here are some of my purpose right here is to be able to, this is the deep root planting for flooding. I think my time is out. Okay. All right, so every 15% increase in the deep root planting can reduce 1 foot of flood water. So my neighbor, 3/4 of the neighbors got flooded by the bayou. So this is from small scale to large scale. So this is our senior project. We're doing a plant box to try to optimize the planting for permaculture. This is the air quality simulation. We're using Indian data. So I would like to have Houston data. This we're doing the earthquake prediction model, so we can apply it to do the flooding prediction or other predictions. So this one is using the climate prediction. This is all done by my students. Okay. So in Ohio State University, they are forming this icicle intelligence data base. So they put all the data in the world, including IoT data. So they say if you are a farmer, you're going to decide when should I harvest my apple, so that I can maximize the profit and minimize the waste. You just go into this database and then you apply your AI optimization. So how do we make decisions? So this is an example using quantum computer, my students working. So if you want to form a team of the Pokemon, a battle team, what is the best way? So we can use the same idea to try. They say you have like 10 policies, and how do we reduce to 3? Or what combination of policies is gonna give you the best coverage? It's kind of like if you're taking 15 drugs, or, we're getting old. This is my 34 years here. So then doctor is gonna have a meeting, say, how can we minimize the number of drugs? Okay, so it's, to celebrate, I'm going to plant this rose. My boss sent me this rose, so sweet. So that's me. This is a picture I took on campus. Thank you.